Welcome to Tenerife Summer Sessions. I'm Uday Yedluri. I'm a senior system engineer. I worked on different environments, including public sector, private sector, service sector, automobile. So I worked for different enterprises. That includes very large enterprises. Today, I'm going to discuss about how to orchestrating multi-cloud innovation for enterprise excellence. How to build a scalable, intelligent, and secure enterprise cloud platforms. So the enterprise cloud evolution, if we talk about enterprise cloud evolution, comes very first thing, and multi-provider reality, strategic capability are the three important things. Through digital transformation, we can reshape enterprise IT from isolated deployments to integrated ecosystem. To understand where we are going, we must look at how enterprise cloud systems have evolved actually. So digital transformation has fundamentally reshaped enterprise IT, moving us away from isolated deployments toward fully integrated ecosystem. Today, organizations rarely rely on single cloud provider. I mean, it's a hassle actually. I mean, it's not a cost-effective solution. Also, it comes with a lot of its disadvantages depending on one single provider. Operating in multi-provider reality has evolved from the technical necessity into the core strategic capabilities that empowers business to innovate continuously. The major players include AWS, Azure, Google Cloud, or Oracle Cloud, IBM. Those are the ones we know. But there are hundreds of other providers provide their solution as a SaaS solution or providing cloud providing solutions. And some enterprises started deploying their own private cloud, which we traditionally used to call on-prem infrastructure. But it's no more an on-prem infrastructure with introduction of VCF or other similar products on-prem in on-prem data center where deployment is way faster and changes are flexible. So with that approach, actually, even on-prem clouds are also a huge success, actually. Let's talk about why organizations choose multi-cloud. First thing is vendor lock-in, global operations, regulatory compliance, resilience, and recovery. So why exactly do enterprise organizations choose multi-cloud strategies? There are thriving pillars. First, it allows us to avoid vendor lock-in, minimizing dependency on any single provider. And with these cloud providers, the cost is astronomical. Some of them, like who I know organizations who moved to the cloud by looking at the cost from the initial cost calculator, where it says $1 million for the specific servers to host on a cloud for next year, 1 year. But in reality, it will change a lot actually. So the cost will, I mean, I've seen bills coming to 3.5 million where they estimated 1 million. So that's one. And it is not easy for a production environment to move from one environment to another environment. I mean to say one cloud provider to another cloud provider, right? So that's one major thing actually, cost optimization, where you need to keep it competitive. And also same time you take the advantage of other cloud providers, what other cloud providers are willing to offer us. Same time, that way we are minimizing the dependency on any one of them. Licensing optimization, license cost optimization happens same time actually. So, and also it makes global operations way easier by leveraging the best localized services across different geographical regions. It ensures strict adherence to the data residency and regulatory compliance. If we look at China don't allow its user data to be shared outside of the China. A lot of times it restricts a lot of data to be stay in China only. So in that case, let's say if AWS is not hosting their services there, I'm just giving you an example. They can host with Alibaba, so provider like Alibaba, Ali Cloud. And also, US also similar has similar things actually, where US federal data cannot be shared outside. So US only uses FedRAMP or Fed based cloud providers. That way, no data from the federal goes out of the US soil. It significantly improves disaster recovery, blastering system, and resilience across environment. And to add to this, the way we can also take advantage of multi-cloud is by using a standard backup environment. Let's say Commvault or Avamar. So non-cloud based or cloud localized backups, instead of using cloud localized backups, we should be using the standard backup solutions by third-party provider. That way we can take advantage of the provider backup solution, and even migrate if we want to migrate from one cloud provider to another cloud provider, or we are backing up in one cloud provider and we can restore it to a different cloud provider. That's a great advantage of doing it. Let's talk about the challenges with the multi-cloud environments. So operational complexity is one big thing, but we have a lot of third-party tools coming these days where we can see all the cloud environments in one pane, and the costs also in one pane. Uh, Before, it was a big challenge, but I'll say now we have a reasonably decent product in the market for a very reasonable price, where with recommendations and security, what are we doing, cost visibility, all of these features, governance features actually coming into one pane. So we can take advantage of that. I mean, it's still a big challenge for a lot of enterprises. People need to onboard by taking advantage of these products. Or VMware VCF has an advantage where you can add all these cloud providers and monitor their products from VCF environment actually, and even cost also we can control or look at the costs and everything. We can take third-party tools advantage. That way we can address these challenges of multi-cloud environments. Let's go to the multi-cloud architecture. To tame this complexity, we look at the structured enterprise architecture as shown in the pyramid. Every layer contributes to overarching scalability and resilience. At the foundation, we have monitoring, observability, security, identity, and networking. Moving up, we manage the infrastructure and core cloud platform services. These support our containerized environments and APIs, which ultimately deliver secure and high-performing business applications to our end users. Sorry, where is this? Okay, this. So let's talk about container orchestration across clouds. At the heart of the modern cloud native portability is container orchestration. By abstracting the underlying hardware, technologies like Kubernetes allow us to achieve absolute workload portability, enabling applications to run consistently across any provider. That's the greatest advantage of container. After containerization started, the IT transformation, new era of IT transformation is started, I'll say. The production application, critical applications, production application servers can be redeployed and stood up with a like one script, or complete server and application configuration is in one single file, and with containers you can just stand up anywhere within like few seconds actually. I mean, that's amazing how containerization evolved and how it works these days to support production workloads, and with a very minimum resource requirement actually. I mean, overhead. So we can cut a lot of overhead with the resource and capacity. This architecture provides demands and guarantees high availability through platform independence and orchestration. So let's talk about infrastructure as a code. To maintain order across these environments, infrastructure as a code is a non-negotiable thing actually. It matters because it eliminates configuration drift through repeatable template-driven deployments. Because infrastructure is written as a code, it has entirely version controlled. That's the greatest advantage when infrastructure is a code. Auditable and easily reversible. Like rollback is like possible. This automation drastically reduces manual effort, enabling faster delivery cycles and rapid disaster recovery. So that's the greatest advantage of taking infrastructure as a code. Let's talk about enterprise automation pipeline and visual elements, right? So here we're looking at the requirements, infrastructure code, and CI, CD validation. So let's bring what this brings actually to us for an enterprise. This brings us an enterprise automation pipeline by integrating required requirements into infrastructure as a code and continuous integration, then following seamlessly through continuous delivery to automated validations. So with this process, we avoid a lot of human error, and this is a continuous pipeline, which is like what truly empowers scalable cloud operations at a scale actually. So this with this it shortens the time to market while keeping environment securely aligned. This is one of the best solutions, and how amazing we transformed from traditional IT to infrastructure as a code. Let's talk about the new way of cloud optimization, which is a AI-driven cloud optimization. From last couple of years, we are hearing a lot of AI-driven cloud optimization, and we are also like, if you are using any cloud provider, we see optimization requirement recommendations. How can we control the cost? Where the capacity utilization is going waste, and even analysis. Right? If there is an issue, we can debug the logs in a single pane where we can interact with the Azure Copilot within the Azure Cloud or AWS, where they will they will read all our logs, identify errors, provide recommendations, and in this there are multiple types of recommendations, right? Part of optimization, environment optimization is one way of doing it, and avoiding errors and increasing availability is another thing actually. So with this actually incidents response time goes like rapid fast, capacity planning is easy, other operational constraints can be handled like seamlessly. As network scale, managing them manually becomes impossible, right? As environment and network scale. So that's where the AI operations hub steps in. AI transformation, cloud operations from relative model to proactive one. Sorry, reactive, I mean to say, reactive one to proactive one by conditionally analyzing performance monitorings, anomaly detections, predictive maintenance. That's what we spoke about. Predictive maintenance, capacity planning, AI empowers data-driven decisions. Obviously, it's important to note AI does not replace engineers, right? A lot of people have as a thought where agentic AI or AI will take out the jobs, but AI will help admin to resolve the issue. End of the day, admin has to get in there. AI might be able to uh, go ahead and give instruction to a server to do a reboot or something like that, but that still most of the times won't resolve the issue, and we are still not there, and engineers are still not need to be there, and they need to be helping the AI, I mean taking the feedback from AI and resolving the issue more efficiently and more quickly, so that environment save millions of dollars of cost over downtimes and by providing reliable solutions to the users. So intelligent cloud operations, right? We spoke about already this. It's pretty similar. Performance monitoring, anomaly detection, predictive maintenance, source optimization. So this is pretty similar to what we spoke before and AI driven. So I already explained some of these on the in previous slide. And yeah, I mean, if you see this as AI operations hub, so these are the couple advantages we are getting: performance monitoring, anomaly detection, predictive maintenance, resource optimization, resource incident response, and capacity planning. Security in multi-cloud. Let's talk about security in multi-cloud. So with this multi-cloud environment, actually, where it's an overhead, actually, user management. Now, this becomes overhead when you manage environment separately. It should be a single sign-on. When we do single sign-on, we also have enforced policies from the security and enterprise to have zero trust, encryption, and threat detection, right? So it's a bit of challenge when we are hosting environments in multi-cloud, and same time we have to maintain zero trust and encryption, threat detection, and everything. So, it requires a fundamental paradigm shift. We must build on an identity and zero trust framework, verifying every single access request, that trusting nothing implicitly. Encryption and strict rate management must protect data both in transit and at rest, combined with advanced threat detection and rigorous network segmentation. Security must be embedded into the every single stage of cloud operations, never treated as an afterthought. That's one of the most important thing. A lot of people implement the environments, and then like, oh, we did not implemented this, we forgot this, oh no, this is not secure. They find these things part of the audit actually at later time, and then they started implementing, which causes some challenges. And no, it's not easy as an if we do it as an afterthought. It should be a planned thing ahead, way ahead actually. That way, it's easy to govern things, and it is compliant, right? And that's what we're going to talk in next slide: governance and compliance. These go hand in hand with security. A mature governance framework consists of three pillars: automated policy management to enforce standard uniformly. Second, continuous compliance validation to audit configurations in real time against strict regulatory requirements. So, and third one is clear risk and accountability mapping, achieved through robust resource tagging and rigorous operational ownership. Tags are like magical things actually in the cloud environments. So, without tags, like we cannot even survive. Tags will help us in every possible way actually. So next is observability across clouds, right? uh, so we are talking about unified log management, end-to-end metrics and tracing, intelligent alerting and root cause analysis. So we cannot secure or optimize what we cannot see. That's the most important thing. So multi-cloud observability requires unified log management and consolidate logs into a single source of truth. So that way it eliminates the visibility of blind spots. We also can utilize end-to-end matrix to distribute tracing to map application behavior across environments. Intelligent alerting leverages AI to filter out background noise, pinpointing root cause when there is an issue, or when users are impacted. It's easy, like AI can easily identify the issue. Our AI research tools. So those are the few advantages, right? I mean, monitoring is a key element, and putting all the logs together is one key element. And when there is an issue, it is easy for us to dig into them and then get right answers. And these days, like with all the tools and everything, we don't need to even dig into the each one of them, right? The tool itself like helps us to look at what exactly happening and what is the solution for some of them actually. Or sometimes most of the cases, like we can resolve it there and then actually. We don't even need to reach vendor. So some industry examples. Let's talk about some industry examples. Secure digital banking, business outcomes, faster transactions are some of the some of them. Let's look into how this plays out in a real world, right? In financial service sector, institutions leverage resilient multi-cloud architectures for secure digital banking. The business outcomes speak for themselves: faster transactions through optimized processing, high availability coupled with strict regulatory compliance, and heavily mitigated risk via proven disaster recovery models. Let's talk about some industry examples too. So other industries see equal success in healthcare. Multi-cloud enables secure patient data management, accelerated analytics, and compliance research. I did work for some healthcare enterprises. I know how important to secure patient data because of the compliance reasons. Uh, and they also want to analyze the PBM data or patient data uh, to identify the trends so that they can create their business approach the data. What is selling, what type of diseases are more coming, what type of insurance people are taking. I mean, but none of this data can go out of the enterprise, and has a lot of restrictions around it actually. So it gives different experience, right? Deep supply chain visibility, particularly when you have like CVS or Walgreens. Let's talk about them, right? What happens is when you know the patient data and what they are going through, what they are purchasing, how their prescription medicine is, how their daily life necessities are. So they can plan their retail actually. So it's all correlated, right? If we are talking about one enterprise healthcare system, this is correlated. Similarly, like if you talk about manufacturing, edge to cloud computing fuels connected factories, allowing predictive maintenance to drive shop floor efficiency. Same government sector. Government sector also is pretty efficient for end user to get services way faster and efficiently. And cross team coordination is possible with this actually. Best practice for enterprise success. To wrap up our tactical approach, let's look at the foundational best practices for enterprise success. First, standardize and automate by leveraging reusable infrastructure as a code templates. Second, govern and secure by designing inherently resilient architectures that prioritize cloud native services. And third, monitor and collaborate, ensure deep visibility while fostering strong alignment across engineering teams. The future of multi cloud innovation. Looking ahead, the future of multi-cloud is highly automated. We are moving rapidly towards AI-assisted ops, handling routine systems, adjustments, and platform engineering, giving internal developers self-service portals to accelerate delivery. We also see seamless integration with edge to cloud, culminating in autonomous infrastructure and self-managing, deeply sustainable, and highly scalable environments. Let's talk about key takeaways of this actually. Before we conclude, let's comment our key takeaways. Multi-cloud is a business strategy, not just a technical deployment. Automate everything using containers, that is infrastructure as a code, to guarantee velocity and portability. Prioritize governance and observability to strengthen the security and reliability. And finally, AI with strict standardization to integrate with AI to strict standardization to unlock true enterprise excellence. The multi-cloud mindset. So enterprise innovation is achieved not by choosing a single cloud, but by orchestrating multiple cloud capabilities through automation, governance, intelligence, and resilience architecture. The organizations that thrive tomorrow are those that mark time. Appreciate everybody joining this session. Thank you.